Abnormal molar masses. Colligative properties depend on the number of solute. In case when the solute associate or dissociates in solution, abnormal result for colligative properties and obtained. Association of solute. For example, acetic acid dimerizes in benzene due to hydrogen bonding. As shown, two molecules of acetic acid associates. On the other hand, in dissociation of solute, a molecule splits up into two or more parts. For example, acetic acid in water dissociates into CH3COO- and H plus ions. Text. Abnormal molar mass. If molar mass is calculated on basis of delta Tb and delta Tf, for such cases the value obtained is either lower or higher than expected or actual value. This calculated molar mass is called abnormal molar mass. To account for dissociation and association of solute, Van 't Hoff factor was introduced. This factor is defined as L equals to observed colligative property by calculated colligative property. L equals to normal molar mass by abnormal molar mass. Association of solute. Let us consider the case of acetic acid dissolved in benzene. Let the number of mole of acetic acid dissolved be N and it forms dimer in benzene. Initial number of moles of CH3COOH is N and that of CH3COOH twice is 0. After dissociation, moles CH3COOH N into 1 minus alpha and that of CH3COOH twice is N into alpha by 2. We can write total moles of solute N 1 minus alpha plus N into alpha by 2 equals to N into 1 minus alpha by 2. Observed or experimental colligative, for example, rise in boiling point delta Tb dash equals to Kbm dash equals to Kbx equals to N into 1 minus alpha by 2 by W into 1000. Theoretical or calculated colligative delta Tb equals to Kb into M equals to Kb into N by W into 1000. Here W is mass of solvent in grams and Kb is molar boiling point elevation constant. Van 't Hoff factor I equals to experimental colligative by calculated colligative. On solving, I equals to 1 minus alpha by 2. Inclusion of Van 't Hoff factor modifies the equation for colligative properties as follows. Relative lowering of vapor pressure of solvent P1 naught minus P1 by P1 naught equals to I into N2 by N1. Elevation in boiling point delta Tb equals to IKB into M. Depression of freezing point delta Tf equals to IKF into M. Osmotic pressure of solution O equals to IN2 RT by V. Question. 2 gram of benzoic acid dissolved in 25 gram of benzene shows a depression in freezing point equal to 1.62 Kelvin. Molar depression constant for benzene is 4.9 Kelvin kilogram mole inverse. What is the percentage of association of acid if it forms dimmer in solution. Solution. Given that W2 equals to 2 gram, Kf equals to 4.9 Kelvin kilogram mole inverse, W1 equals to 25 gram, delta Tf equals to 1.62 Kelvin. On calculating, we get M2 equals to 4.9 into 2 into 1000 by 25 into 1.62 equals to 241.98 gram mole inverse. Thus, the experimental molar mass of benzoic acid in benzene is equals to 241.98 gram mole inverse. Now considering the following equilibrium for the acid 2C6H5COOH reversible C6H5COOH twice. If X represents the degree of association of the solute, then we would have 1 minus X mole of benzoic acid left in unassociated form and correspondingly XB2 as associated moles of benzoic acid at equilibrium. Therefore, total number of moles of particles at equilibrium is 1 minus X plus X by 2, that is equal to 1 minus X by 2. Thus, total number of moles of particles at equilibrium equals Van't Hoff factor. L equals to normal molar mass by abnormal molar mass equals to 122 upon 241.98 or X by 2 equals to 1 minus 122 by 241.98 equals to 1 minus 0.504 equals to 0.496 or X equals to 2 into 0.496 equals to 0.992. Hence, the degree of association of benzoic acid in benzene is 99.2%.